We've made roughly 15% of our way to the AWS cloud-based quiz application. The backend is far from being ready, but we set up the framework and provided the application with all the resources it requires. The next stop is a complete backend that we'll soon address from our static website. Let's continue implementing endpoints one by one. And let's also find a way to solidify the code to prevent it from failures after adding more features. First, I will go and check what data we need for this quiz start request. And for the quiz start request, we have this topic. This is the ID of the quiz we want to start and the username, the user who starts the quiz and who becomes automatically the quiz commander or the person who actually schedules the quiz. I would go to the API, and here in the API package, in the quiz endpoint collection, I'm going to introduce a new endpoint, and it will be definitely it's a post endpoint quiz start. Quiz start, and the method is post. Probably it's a good idea to also name it start quiz. And we need some data, some input, as it's a post endpoint, and we have to capture the payload that will again contain the topic and the user name. The return value again would be a dictionary of string, keys, and some object test values. I'll define this data in a separate class, in a separate module. And I'm gonna copy the existing class with some payload, no, with some response value that's decorated with pydentic. Rename the new module. It would be quiz requests. And in this new module, I will reuse the existing class, but again, I'll rename it to quiz start request. I need the username and the topic. Let's start with the topic and then the username. And I just thought that this data might not be enough. For instance, while debugging, I want to run a short quiz. We've given the player only 5 seconds for answering each question. But when I run an actual quiz, I'll be demanding more time, reserving more time for answering questions. So this variable, this is an argument for our start quiz request. I would call question seconds of integer type, and this argument would have a default value of 10. So while I'm initializing this quiz start request instance, I don't have to provide all the values, just the topic and the username, and I can omit the question seconds. And this would be the data I will expect in my API here. Now I need an actual implementation of this start request method. Start quiz, and this is just a response. Maybe I would return a response in a form of dictionary, but the only thing that's missing is the implementation of the start quiz method. Now I go to the quiz manager definition, to the class quiz manager, and extend this class with the method oh, This method for now does not have a body. We'll add the implementation soon, but before we have to decide what to return from this method to the user. Let's define the value and let's check what are we going to return from this quiz start method. And we're going to return the quiz status, including the quiz code, maybe the quiz detail as well, the identifier and the name of the quiz. The most important field is the status. Also, I want to know how soon the quiz will expire, and probably I will include here some user data, including the username. Not sure about it, but obviously the user token. The user token that defines that authorizes each user's request for maybe scheduling the quiz or getting the quiz results, and most important, provide the answer for the current quiz question. In this user data, we'll also return the user role because only the commander has the ability to press the Start Quiz button and to schedule the quiz. But again, this is not the role but the token that defines if the action is gonna return 200 or an error response. That operation is not allowed for this type of user. But for the user itself, for the GUI, to render the user role, we'll be using this extra variable. Let's separate this data. Something regarding the quiz will pack in the quiz variable, and the user data, user role, will pack separately. So probably we'll need a new Python module, and it won't be a small one for the quiz state. And let's define the quiz state the same way as we define other Pydantic objects. This quiz state should include the quiz code, as we decided already, and the quiz status. The quiz status is apparently an enumeration, and for this enumeration we have these values from pending to expired. Let's define this class from enumeration. Let's import this enumeration module and define all the states from pending. That means the quiz was created but hasn't been started so far, hasn't been scheduled. And the next state is scheduled. In a fixed time interval, the scheduled quiz would be started. We define this as well. And after a while, it will be finished. It doesn't matter if the user provided the answers or not, we'll finish the quiz eventually. And after a while, maybe in a few hours, the quiz would be expired, probably completely deleted from the Redis cache. But for now, we might define this status. And probably the expiration time as well. Okay, let's go back to this state machine. And this state transition from the scheduled to started time should happen automatically. As well, from the started to finished, we have limited amount of time. And we can calculate the amount of time from started to finished because we know how much time do we need for each answer. And we definitely know how many questions do we have. So if we know the time the quiz started, we might perform this transition, and then we might perform this transition as well. So for me, the most important, or maybe the only time that matters for the quiz, is the starts at daytime. But before we actually schedule the quiz, we don't know at what time this quiz starts. So my suggestion is to make this field a default one. And probably as it's default, we can default its value to none. Also, in the request, the user sends in the quiz start method execution, we have this question seconds variable. Let's keep it in the quiz itself, in the quiz state, because it's a runtime argument. While we define our quiz, we do not define how much time we give each player for answering. So let's have it here in the quiz itself. And we might default this as well to some value, say 10 seconds. Oh, sorry. My fault. Now, probably we'll need more fields here. And while I know at what time quiz started, I can calculate the current question. So if the quiz started 10 minutes ago and I have 1 minute for each question, that means I'm now at the 10th question. But probably it's easier for me to preserve the current question index in the quiz itself. And for the user, it would be much easier to display this data, to work with this data with the current question, if the user knows how many questions does he have in the quiz. We might store it somewhere. We might obtain the number of questions. That would be my second part of this scalar tuple value. But there is nothing bad in having an extra argument, an extra variable here showing the exact amount of the questions in the quiz. And let's default the first value, the actual question index, to -1. Might be that's it for now, but I kinda anticipate we would benefit from having question here because we will return this state to the user and we will return the state with the question itself. But again, we don't know what the question is until we actually start the quiz. So let's default it to empty string probably, or if it's optional to none. That's it for the quiz state, but that's not it for the return value from this method, because we return not only the quiz state, but also the user data. I'm going to introduce the quiz player class the same way I define other classes. It's a pydantic class that could be serialized into JSON easily without extra effort. In this class, the most important value here is the user token, because the user token actually authorizes all user requests. And the username and the user role. Again, if the user just changes the user role variable on the client side and pass this role as a different value to some of the post requests, we'll ignore this value because we'll know the actual user role. We'll check it by the user token. But still we need this role to display it somewhere in GUI. And I'll define the role as another enumeration. Let it be quiz user role, probably. There are two types of users, players and commanders. That's it. I believe that's it for the user. Now we have to combine this data, quiz state, with this data, user role. Oh, I haven't renamed the class. Quiz player, actually. In one response that will return from here from quiz manager. And let's call this combined class. Don't know, maybe user quiz state. The name might not be perfect here, but we'll be able to easily refactor it later on. What matters is actual data inside this class defined here. And the data is definitely the quiz state. And apparently the quiz player data or the user data. Before we go further with actual implementation in the user manager in the quiz manager class, I want to check if I have enough data in this quiz state, in this user quiz state. Maybe I'm missing something. I want to check the GUI we defined recently. And this page, after we start the quiz, shows the time left. The time left might be a separate variable. We'll be decrementing it on the client side. But I haven't decided yet where to include it and should we include it eventually. But we definitely need the question data. We need the user token to include it somewhere. We need the number of the questions in the quiz and the index of the current question. And we need this list of the players. This is just a string or a list of the strings. We'll render this here, player names, and we can highlight the current player. We know the current player name. We can just compare one of these names or each of the name with the current player name and highlight the one that equals, that matches. So we'll go back to the quiz, and here in the quiz user state, we might introduce extra data. All usernames have the list of the strings. Logically, these all usernames might belong to the quiz state. I'm not so sure about putting this data in a separate class, but for now, let's have it here. Again, we can refactor this code later on. So our quiz manager would return this combined state of the quiz itself plus the user data. And this should be enough for the client to render the current state of the quiz, the current question, and to provide the logic of the client with enough inputs for performing the next step, the next action, maybe answering the quiz or maybe requesting the quiz results if the quiz finished. So that's it with the data. Now we need some actual logic. Before performing any action, I would check if this request actually refers to one of the quizzes we have here in this quizzes variable, and this quizzes variable we read from the metadata from maybe S3 storage, but now from the local file system. So I want to find the actual quiz. I'll be using probably list comprehension here. And I'll get all the quizzes with the identifier that matches with the provided data. Actually, I'm missing something. Might be that's topic, or let me rename it for now as a topic identifier. And let me call this variable quizzes. And if it's empty, this means the request contains incorrect topic ID. I want to raise an exception that contains enough detail to easily trace the root cause of the error. And the root cause might be, for instance, we failed to read quiz data from the local file storage or from the S3 bucket. Or might be the quiz ID just provided incorrectly. And this is also should be in the exception detail. I want to show that this particular topic ID is missing or wasn't found. And I want to indicate how many topics have we read as well. For instance, if we haven't read a single topic here, if this variable is empty, the exception would contain enough detail for us to understand that something went wrong, probably in the very beginning, while we were reading the quizzes. Otherwise, we have the quiz or the quiz metadata. And we can probably start constructing the state we'll return to the user. I would start from the quiz state. Later on, I will add the user detail as well. Let me check what we need here. And we need all these variables. Starting from the quiz code. Quiz code is something that we're going to share with other users, that the commander will share with the rest of the users. And quiz code should be human readable and should be unique. As it should be human readable, it cannot be a unique identifier. It should be something shorter, probably an integer, ranging from 0 to 100,000. I believe that would be okay for our pen test. It's not a production application. We don't care about collisions. Collisions could happen, but chances we have a collision in our tests are close to 0. And the quiz status, that's for now is just pending, because we are starting the quiz, and in order to make the quiz actually started, we should schedule it. But we didn't do scheduling in this very request. And the expiration we should calculate. Probably we have to define one extra method, because everywhere throughout the quiz I want to use UTC times. It might be better because, for instance, I might share UTC time with the end user, with the client, and client could have a different time zone. So if we define for ourselves that the time could be UTC, always UTC, we can avoid having troubles of storing preserving time zones. First, I want to get UTC now. And UTC now could be easily gotten from the datetime There is UTC now, but the problem is the value returned by this function won't be having any indication of the time zone. So Python might be tricked by this variable. Sometimes it decides that this is not a UTC time zone, but a local time zone, and would try to perform time zone conversion. In order to prevent us from having time zones treated incorrectly, we'll provide the time zone info, and the time zone info will be daytime, time zone, no, time zone should be probably, yep, UTC. Now I'm gonna shift time forward from the present moment and seconds ahead. Time delta I need, no, this one. The amount of seconds would be a constant, but having this constant here is not a good option because might be we want to change it and I don't want to look through the whole code to see this value and to change it for something else. So I'll introduce and name it constant. I'll create a separate model for these constants. Let it be quiz expiration seconds. But I also want to be specific here that's pending quiz expiration seconds. Because might be if the quiz hasn't started already, we don't want to store this data in memory for too long. Chances are user can change his mind and not starting the quiz at all. But if the quiz has actually started, we need to preserve the results for a bit longer, maybe for a couple hours, to be able to share results with other users until they're expired and eliminated from memory. And also I want to introduce a class here. Let it be quiz constants, because I want to collect all the constants in one class, and I want to import just this class and use the class static variable, the class variable, here instead of this. Also, I don't like this code because I probably will be calculating this UTC time now, changing the time zone specifically for time zone UTC multiple times. And I don't want to repeat myself. That's why I'm going to introduce one more model here. Not sure if it's about domain. Let us move it in SRC. For now, it's just generic utilities that I have in one place. Later on, I might be more specific. Let me call it get. It's starting from verb, UTC, time now. Now time. Sounds better. I believe that's it. I can use this function instead of this ugly code. I don't need an extra variable. Let it be just expires at. Finally, one more argument is provided. And the starts at is still unclear for us because the user hasn't scheduled the quiz yet. So this means none. But the question seconds we already have in the request data. And we're going to use this data directly here. I will also default these values, current question and current question index, because the default ones work for me. And now I have the state, and I'll return this state to the user with the user data, with user token, username, might be something else as well. But I want to store this data in the database, in our case in Redis. I don't have an ability to store this data now because I don't have a specific class, maybe something in the data access layer, but this class is missing for now. And let me leave here to do store the state. And now I'll define the data will return to the user, the data about the user himself. This probably belongs to here, quiz state. This is a part of quiz state or user quiz state, quiz player. Actually, we know all these values except for the token. We can easily create a token. It will be just a unique identifier. And to create a unique identifier, I will use a special class, UUID, UID4. But let me check this code. I'm not sure if I'm getting the string as a return value. Most probably it won't be a string. I'm going to check the Python console here. And probably I have to first install this UID. Oh, no, import this UID module. And what's the return value of this function UID4? It's just UUID object. I want to stringify it. So if I stringify this, I'll get what I need. And the name is actually in request again. And the user role, we know it already, it's commander. That's it. Now we know what data we return to the user. And this is the combination of the quiz state and the user data. And this includes the state. I believe it's called the state. And the user data. And also all the names of the players participating in the quiz. I know all the names already, and this is just it. Player data name. I also have to store this data somewhere. I'm not sure about where to store it now, but definitely it's again the Redis database or database with the quotes in there. But at least I can return this data now and I can test this new endpoint. Before going to file, I'm going to start the quiz and check if the payload is okay for this request. In the quiz API, here, quiz start, and the response is what I expect. Oh, I'm actually not returning anything until now. Okay, Let me start the application. And as I see there is no error here, this is a good sign. I'm gonna go back to the terminal and I'm gonna start typing my request. In my request again, curl ix for extra output in case of error. I will be posting and the endpoint would be HTTP localhost. The port is 8055 and the root API is just API. Let me check if it's API or something else. Yeah, I see the prefix here. But the specific endpoint is quiz start. Actually, I need some data here, and I will provide this data, but let me edit this multi-line request somewhere else. Say Sublime. I need a payload, and it will be what we expect in the quiz.request class. Topic ID, username, and question seconds. Question seconds. Now the topic ID, where do I get one? Here. It's just the folder name, and I will rename it. Actually, I don't want to rename. I'll just copy and paste the folder name that's ID here. Yep, this data is a good payload, I believe. But I got an error. We expect some different input. Let me check my request again. Okay, might be there is something I missed, and this is the header. I should specify the content type. Application JSON. Yeah, no. Now the spelling is correct. The payload should be correct again. And what I got is internal server error. I want to debug this. Serialize response gave me an error. Probably that means the whole request was processed, but the API layer wasn't able to serialize the data I return here. But now I can debug it actually. I don't want to run. I want to debug the project. And I initialize my request again. What's the response? Quiz, user quiz state. Oh, actually I'm saying I'm returning a list of dictionaries. That's not true. But let me check what's happening when I convert this object to the dictionary. Again, I'm requesting the same data, and the return value is a dictionary. I can see it clearly. And all the data is here, both the state and the user. But what's happening next? Oh, it's actually completed. And in response, I have all the data I expected, including the state and the user token, name, and the user role. And all usernames, again, here is my username. Now what I'm going to do is to get rid of these to-dos, because to-dos constantly irritate me. And in the quiz manager, I have the to-do here. Right there, I wanna store this state of the quiz in the Redis database, but this is not implemented yet, and I have already a Redis repository, quiz state repository. I could test it. Let's check if Redis is running. Yeah, it is. I can use this code. I have the Redis client. Now I want to store the quiz state. I will be using set state, and I should pass the quiz state. That is actually quiz state. And let me define the expiration period for each of the record I'm gonna store in Redis. Because I don't want to get my Redis a trash bin for the old quizzes, for the old data I don't need any longer, because this data will occupy the resource in cloud, and I don't want to pay extra for the resource I don't use. Now this Redis client, I can use this set method, and I should actually provide a key. I might have a convention or a separate function to convert the quiz name to the key, but let it be simply quiz and the quiz code inside. Quiz state with the quiz code is my key. It might be the quiz ID as well, but we kinda rely on the quiz code. We believe it will be unique. There might be collisions, but if you go production, in production, we'll replace this logic, we'll replace this quiz code generation to ensure uniqueness. And now we need the actual state, and as it's a pydantic data class JSON, I could serialize it to JSON easily without extra effort. And the rest that I need here, let me check what arguments. Yes, it's here. Keep TTL and X. Okay, maybe I'll check the Redis client. Not here. Oh, I already had it somewhere in my search history. And this is X argument in seconds. X equals to expiration seconds. But there is some special case about this argument. Let's go back to the quiz client. And X is actually nullable, optional argument. So might be if I don't want to provide anything here as expiration seconds, it might be the case for me that I set expiration seconds to 0. I should specify none, not 0. I'm not sure about Redis is okay with 0. Let me check. First, let's try some actual value, 10 seconds. That's okay. And second, let's try 0. No, 0 is obviously not okay. I could use this. I'm not sure if I need it, because my final goal is to get rid of the data in Redis as soon as I don't need this data any longer. But maybe for now, expiration seconds or no is a good option for me. For instance, if I provide the value this way, there should be no error. Yeah, that's okay. Let me also check I can get the state. I will serialize this data directly to JSON, but using the quiz repository. I won't be using this Redis CLI any longer. Instead, I will set state, and I need this quiz state here. And let me check how do I construct the quiz state in the quiz manager. Copy and paste it here in the repository. It's just random. Expiration time. How do I get it here? Yep. Oh, I need too much data. But still I want to test it now. Later on we'll probably test it automatically. So far we don't have a single unit test, but we'll fix it soon. And finally question second, let default it to 10. And upon setting the state, oh, I have to provide something else, expiration seconds. I don't know, maybe 10 seconds would be enough, 12. I want to read this data as well, and I want to call this Redis CLI get. I don't have this so far. I will implement it soon, but not now. And the name, what the name is, it's here. Let me initialize this variable first in a separate variable definition, quiz state. And the test. Okay, I stored the value and was able to read the value. I will need it soon, but not now. What I need now is to use this quiz state repository here in the quiz manager. I don't have the repository so far, but I'm going to introduce it. Let it be state repo. I'm prefixing the state repo with underscore because it's kind of internal variable. I don't want to use this variable outside this quiz manager. And as simple as this, as I do in the main.py, I'm gonna set state here instead of this ugly to do. And the state is here. And the expiration time, probably again, it's quiz constant pending quiz expiration seconds. And I need to store the user data as well. But I see here one problem. I will be storing one quiz user data. That's not enough for the whole quiz. I need the state or I don't know, some data collected for every quiz user, including the answers they provided, including their names and their tokens and their roles. So I don't want to store the single user. I need the collection of users to store. And this collection we still have to define. I believe it's okay for us to call it quiz players. Quiz players. And this is just a collection of these records. That's it. I want to store actually this data, quiz players. I go back to my state repository and add this quiz player set method. Let's copy paste the existing one. The changes are minor. Set quiz players. And what I'm storing actually is quiz players. Oh, not this one. But I wanna bind this quiz player collection to the quiz code, so I need the quiz code as well. I do have quiz code here in set state in the quiz state variable, but here I don't, so quiz code comes separately as an extra argument. I'll be using this argument directly here because I don't have anything like quiz state, and I call it quiz players and the code. And that's it. Oh, sorry, quiz players. Now I can store this data in the repository, not in the quiz manager. Almost the same way I store it a couple lines above for the state. Set quiz players. I don't have quiz players so far, but I'll initialize this class easily. And what do I have for the quiz players? A special class with just one argument, players, equals to this collection of one player. And I also need the expiration time, and it's the same. Now, what I'm missing? Oh, I'm not using this detail here. I'm not using the quiz detail. Might be will benefit on the client side from the data of the quiz, metadata, the quiz topic name, and the quiz identifier. I'm not sure so far if we use this data later on, but let's consider including the quiz metadata here in the quiz state. I'm extending this class with a couple more arguments, with a couple more class variables, ID of the quiz and the name of the quiz. I would probably change this naming, but I have the same names here as I have for the quiz topic. So let it be for now name and ID. Later on, I will rename it because it should definitely be isolated, at least logically, with prefixes, indicating that this is a metadata of the quiz itself, the data that doesn't get changed during the quiz. And I have to provide this data. Now I see the arguments list for the quiz state constructor is incomplete. And ID I got from the quiz and the name as well. I probably missed something else. And what I'm missing, again, I'm returning to the idea of having the next update time in the quiz state. In this case, we don't know this value. So the time of the next update is not determined yet. We should do it later on. I'm not sure. Maybe upon scheduling the quiz, will indicate the number of seconds left for the quiz to get started. And upon receiving question number 1, will indicate the time for the question number 2 and so on. So inside the quiz state, we'll probably should introduce one more variable. And this variable, let's decide on naming. It should be, okay, it's indicate the time of the next update. and let it be updates in seconds. This quiz updates in 7 seconds in our example. It's an integer type. It equals to -1 probably, because this quiz is not scheduled yet. This time is undetermined. But inside our quiz manager, I don't have to update this code because I don't know yet when the quiz starts. So I'm good here. And the next thing I'm gonna do is to test my quiz, not in a manual manner as I did previously. Let me repeat it. I run my application, web server, go to terminal and run this CRL command. Okay, everything's fine. And I see updates in second, the new field I added is -1. I want to check in the internet, how do I test async API? Python test async API. And here it is. I can probably reuse this code. I'm going to introduce tests, automated tests, but they would look like a unit test. Definitely that's not unit, but rather integration tests. So I'm introducing the new model, the new package, tests, and inside API. And inside I'm gonna test, I don't know, probably start quiz API, but let me start with something ad hoc, test quiz. I'll rename it later on. I'll copy paste this code. Okay, so far it looks good, but I don't have these libraries installed, and I'm gonna install them, add them to my virtual environment. It's activated. Oh, every time I add a library, I add a module to the project, I check if my virtual environment is activated. If it's not, I will activate it again. And I check, yes, I'm in a virtual environment. So I'm gonna install PyTest. Now in a while, this error, yes, it disappears. Also, I'm installing HTTPX. And let's not to forget to actually store the requirements. Pip freeze. And let's redirect the output to requirements txt. Fine. Oh, we have already too many requirements. But the most important one, I have PyTest here, and I have HTTPS here. My application model is not here. Probably just, let me check the relative path. Yep, it should be main.py. Oh, it's actually on the top level. Okay. I could run my test, but not against this particular path. I'm not sure about the path, but definitely I have a prefix API. And let me test. Quiz topics probably is the simplest endpoint to test. API quiz topics. Let's just asset the response JSON is not empty. And let's print it. test failed. It says there is no model named trio. What does this mean? Okay, I need a bit of investigating here. I'm not sure if this is the case, but probably I don't need any IO. It's async test, so I want to have this async IO. Let me check what happens after this small change. Again, first it was green, but finally there is an error message. And the error message is saying that async dev function and no async plugin installed. Let me try installing this async. Now, running the test again. The same result. Or probably I need a specific plugin for PyTest async. Let me check if it's better now. Oh yes, test passed. So I was able to receive the quiz topics. And I want to check, do I have that? Yes, I do have the quiz topics here in the response. Now I want to reuse this code. So I don't want to specify each time the async client here in a unit test. Instead, I want to rely on the async client I create probably in the ad hoc testing model. I will rename the model. I will name it API test client probably. Yep. I'm gonna reuse this client. I want to introduce this as a named constant. Maybe I'll use it later. Not so sure. It might be the part of the URL. And also, I believe I will be using these clients passing not only this URL in the GET request, but some data and some headers as well in POST request. So for the POST request, I need this content type to pass. But before I do this, I want to introduce a unit test for getting the quiz topics or integration test. As I often do, I'll start from copy pasting. I'll paste this model here. I'll rename it. It might be test. It will start with test definitely. Test quiz topics. And in this test, I will reuse the async client. So my response will be equal to await responses client, get the same URL, and I'll check that response not empty, and I'll check that response is an array or a list of 2 elements. So response JSON is here. I'll check that its length is equals to 2. two quiz topics. Some imports I don't need any longer, I'll remove it. Do I need the test base URL? No, probably not. And going back to the API test client definition, I don't need this code as well. Great, we have the first integration test, and we have two methods, get the quiz topics and start the quiz. And one method we already covered with test. So I want to introduce one more method for starting the quiz. But first I'll rename this test. Test quiz topics. And again, I will copy and paste this test in the same package. But it will be test quiz start. It will be a post request. Quiz start. And I need some payload. This payload is actually JSON. How do I provide the payload? Most probably this would be, let me check. What arguments do I have here? It's a data or it's a JSON. I believe it should be JSON. JSON equals to quiz start request payload, and I'm already creating it somewhere. I'm checking the domain quiz requests, quiz start request to JSON. Again, I need the topic ID. The topic ID is here. The username and the question seconds. And I'll need headers. That's just content type, application JSON. But I will use these headers here and there in a number of quiz method tests. So I wanna reuse this data in this API client. Let me give it this a name. It would be named constants, headers, JSON, content type. The name of the constant or a variable is almost as long as the name of the actual payload. But again, having a named constant or a variable is much better than copy and pasting this data. Let's check if it works and what we have in the output. No, it doesn't. It says that the quiz start request is not JSON serializable. Oh, yes. I want to convert it to JSON first, and then pass the JSON to this test method. Okay. The response is 422. That's not what I expected. I'm not sure about what I'm pasting here. Yes, this is not a data dictionary. Probably this method expects a dictionary, but actually these two JSON I use in my Redis repository here to JSON, and Redis expects a string. But in our case, this method expects a dictionary. So let's go back and try to replace these with two dict. Yep, that works. I could check something else in the response. For instance, assertion against the response JSON. State is not empty, and state name equals to animal quiz. Not exactly. Yes, of course, the name is a part of the state. Now it works. Joining the existing quiz is the next method I want to implement, and I want to go back to the quiz manager. And as I have this start quiz request, I'll also implement the join quiz request. Plus minus the same way. The request is different, of course. Let it be quiz join request. And in this request, I expect definitely the quiz code. Oh, that is integer type. And the username again, this is string type. Here I need the actual quiz state. So before going further, in my quiz state repository, I should implement a method for reading the quiz state, for returning one that corresponds to the quiz with specific code I provided. Okay, we have set method, we'll add read method, read or get, but actually we are reading the quiz state. And we have the quiz code as the only input required. And we'll return the quiz state. Or actually, we'll need more. We'll need quiz players as well, because the state and the players are all the required data we need here to display the current quiz users, including the user data for the one specific user who opens this window. So we'll be returning a tuple or the quiz state and the quiz players. And we'll again use this Redis CLI to read some value, as we do here, get. And our key is quiz code plus some prefix. This is just a JSON or a string. It could happen that there is no such data. Might be the data is expired, or this ID hasn't been stored anywhere. So this means we are raising the exception with some specific detail about the error. This quiz with this code has not been found. Otherwise, we'll read the quiz state we'll actually use this method or data class JSON from JSON here. And also we need the quiz players. We'll do plus minus the same. Quiz players this time. And the key is different. The error message is different as well. Or might be the same. Slightly different. So we've got the quiz players, we've got the quiz state, and we'll return both. First state, second players. Yes, we can use it. I don't want to use this any longer because we already have tests, integration tests. And as soon as we implement the whole method in the quiz manager, we'll test it. Join quiz. First, we'll read the current quiz state and the quiz players. Read quiz state. The name is not exactly telling us what this method is doing, but we could easily refactor it in future later on, not now. But now we need just the quiz code, and this quiz code is in the request data. And if something goes wrong, we'll have the exception inside the method, the exception we just defined. So I don't want to test this, but now I'm gonna check what is the role of the user that we know from the request data. Might be the user is already among the quiz users on the quiz user list. So technically we can have a conflict when two users with the same names try to join the same quiz. I want to check it. I could check it easily. The username. If it's already in the quiz players, actually quiz players is a list of objects, so we can use set comprehension in this case. And from each of the player, we'll get, what do we get? That's not exactly quiz players, but quiz players and players list. And we check the name. And in this case, we'll raise an exception. And the exception is user name. This name is already occupied. If it's not the case, we'll update the quiz players list with the current player data. And the current quiz player, again, we create almost the same way we did it before while starting the quiz. The only difference is the role. And the user role is player, just player. Now we should update user players, as we did previously while starting the quiz. And the players, you already have this variable. And the quiz code we have in the request data. And the quiz expression seconds is the same value because the quiz hasn't been scheduled yet. So what do we return? We return user quiz state, yes. And the user quiz state, probably we should create now, as we did here, user quiz state. The state is what we read, as well as the quiz players. Oh, that's not exactly it. We are returning the state for the current player only. So this is the last player. The last value they added to this list, this one. And all usernames is simple, list comprehension again. But we need the names only. And this is the data we return. Now let's go and test this quiz method. And we miss the API, probably I'll check here in the quiz. Yes, we have quiz start, but we don't have quiz join so far. This will fix soon. Instead of start quiz, we are running join quiz, but the rest is the same. And now for the tests. We are testing quick start. Again, I'm copying and pasting the whole model here. Test quiz join. But before joining the quiz, I have to start the quiz. So I would repeat this very request. And in the state, I should get the quiz code. Let me check if I get the quiz code here. Yes, I do. Now I will perform almost the same request, slightly different payload, and I'll check the response then. I only need the quiz code and the username. Let me just print the result to manually check that everything's okay. Not so okay as I expected. Something went wrong. Hmm. I'm not sure what might go wrong, so I will debug this method. And I'm gonna run the same very test in the debug mode. And actually I could go here, but then something went wrong. I wasn't able to obtain the quiz state with the quiz code. So for a while I will place try catch here. And check what I'm having in the exception. Hmm. Key error is ID. ID is not found. Okay. I will go debugging this read quest state method. I will put a breakpoint here and run the debug session again. Okay. JSON data is found. And I'm trying to, yes, I was able to parse this data. Okay. Now I'm trying to get the keyword place data. JSON data, yeah, it is here. Oh, my fault. I was copy pasting and I missed this point. I was trying to construct the wrong class instance from the JSON. Now it should be okay. Let me go back to the quiz manager. I'll remove this exception interception. I don't need this. Let me propagate the exception to the very beginning of the call stack and just run the test. The test was a success. The only problem, I don't want to repeat this code because the majority of the test I'm going to implement will depend on this start quiz request. And this quiz start request I want to have in one place, and this place might be the same model, API test client. I would probably introduce a specific model for this purpose, but for now, let me encapsulate this as a function in the model API test client. The function is start quiz. It's not a test. I need this quiz start request. And here I'm going to return the quiz code. The quiz code is a part of the JSON. I just delete it. Yep, here. I should be okay with this start quiz function. I will reuse it here in the test quiz join. So the quiz code would be await start quiz, and I don't need this whole data. Fine, we tested our start quiz request. Again, what's the output? Let me check that the output contains both state and the user. And we are good here. we have 3 tests already. And if I'm gonna change something, I will be not so sure that I'm not breaking anything in my logic. So I wanna run these tests. I wanna perform a regression test in iteration to check that everything I have been implementing so far is still functioning. I don't wanna go to every test model and run it manually. Instead, I will run them from the single makefile command. I will introduce this makefile command here. I will call it simple test. I'm copy and pasting because I need these tab symbols, and it's not easy to insert the tab symbols in PyCharm. So I would just copy. And I would run this command python m pytest. And the package is tests. Let me check if it works. Directory test not found because it belongs to src. So I want to cd src first and next run this command. Good, 3 tests passed. And now I may run this command in a different way, make test. I don't have to cd to src because makefile is one directory up. Make test. Okay. Now I'm going to continue implementing more methods for this quiz manager class, and the next method would be to actually schedule the quiz. Scheduling the quiz is the next command that probably resembles the existing command, join quiz, at least a bit. I need a special request. Probably the new one should be schedule quiz request or quiz schedule request. Anyway, I need a delay in seconds. How do I call it? Let it be delay seconds to be more specific. I'm not sure about what to return, but probably it's again the quiz user state, containing both the state of the quiz and the user data, including the user token and the user role. So I'm starting with obtaining this quiz state and quiz players. And also I want to check if the current player who tries to schedule the quiz is the quiz commander. So I want to check using the list comprehension, the user rights. I want to first select the user. I couldn't copy paste any code, unfortunately, but that's okay. We need only users whose user token is the same as of the request data. Oh, we are missing the user token. Actually, there could be only one user with this user token, but 0 users is a possible outcome as well. So if there is no such user, we'll raise an exception saying that the user token, what's wrong about the user token? Probably it was not just found, not found among the quiz users. And Finally, we are checking the user role. Is it a quiz commander? And the user role, if it's not equal to quiz user role commander, let's raise another exception saying the current user is not a quiz commander. What are we going to do now? We are updating the quiz state. We have the state already. But now the status is scheduled. And we actually know at what time the quiz starts, and this time we can calculate almost the same time, almost the same way we were calculating expiration time. So get UTC time now starts at plus time delta, and time delta is coming from the request. It's delay seconds. And actually there is one extra field we added just recently. And this field tells the GUI, the front end, how much time is left for the next action, for the next update. And this is updates in seconds. And this is simple as delay seconds. Probably I should store the state now. I should set the state. Set state. And the state is just a queue state that's already initialized and updated. And now the expiration time. We have already expiration time for the quiz that hasn't been started so far. But let's imagine the quiz was started already. And it might take longer for the quiz to end than, say, 10 minutes. Let's maybe increase this time. Let it be started. Quiz expiration seconds. Let it be 1 hour. But that's not it, because the quiz could take substantial time to complete, and we might want to extend this time, adding extra seconds here. We can calculate this time by the amount of questions in the quiz, multiplied by the delay between the questions. I'm not so sure now about us having to include this time calculation here. For simplicity, we might leave it just started quiz expiration seconds, or at least we could add here the seconds in the request data. Oh, sorry, I was updating the wrong method. Actually, I want to update this. Request data, delay seconds. Some extra calculation we could include later on, but for now I'm okay with what we have. We just have to return the state, and the state is combined user quiz state. We probably are returning it already. And the user quiz state consists of the state and the quiz players, but not the last one, but the current player, current user. Current user is not necessarily the last one. Most probably it's the first one, the quiz commander. But let us not rely on the quiz commander occupying the first position on the list. Instead, let's take the current user. And all usernames we receive the same way. So just now we introduced one more method to the quiz manager, and we have to introduce the API method as well. It should be quiz schedule. Schedule quiz. The request is different. But that's it already. We might want to test this method the same way we tested the quiz start. Test quiz start. I'm starting from copying this whole Python model here, renaming it a bit in a test quiz join. Oh, sorry. Let me take this test quiz join and rename it to test quiz schedule. The difference between the old testing method and the new one is not substantial. Again, we should start the quiz first. And now we are testing the quiz schedule. The request is different as well. The payload is slightly different. User token. Oh, we are missing this user token, but we'll fix it soon. And what's left? Delay seconds. Actually, I'm not sure about my implementation right now, because while scheduling the quiz, how do I get this quiz? I miss the code. Python is a language with dynamic typization, so it doesn't say me there is something wrong about this code, because the request data definitely does not contain the quiz code, but it should. Yes, now we can test it. Schedule quiz request. And the quiz code we already have. The user token we don't have so far. We'll add it soon, a bit later, and let delay second be equal to seconds. But I'm gonna go to this start method function and let it return not just the identifier of the quiz code, sorry, but also the user token for the user who created the quiz. It will be tuple of integer and the string. And the integer is definitely the quiz code, and apparently the string part is the token. The token does not belong to the state, it belongs to the user. I believe it's called user token. I hope that's not just token, but let's see. And the user token we are passing here. And we are joining the quiz. And I want to check that the response JSON status or status code, I'll check later, is actually scheduled. Let me run the quiz test. Oh, fine. But I updated this start quiz method and it's using more than in one place. It's being used in two places, also in quiz join test. And I want to skip this variable user token. I don't want to use it, but I want to declare, but I want to unpack this tuple that's returned by start quiz into values, quiz code and user token. And let me run all the tests all together. Fine, all tests passed. The next and probably the most important request for me is a get state request. Why it's so important? Because remember, we are performing the state transition each time we change we check the state, and each time we perform a special operation like posting an answer to a quiz question. So this get state request might automatically initiate state transition, say from started to finish it, or from scheduled to started. I want to start with something simple. I'm going back to the quiz manager, and now I'm implementing the get quiz status request. Let me copy paste again. And I need these lines as well. The request data. I might capture the payload from the headers. So the user token I'm capturing from the post request, actually I can get from headers, like tokens we used to authorize our request, for instance, JWT token, but not in this case. In this case, I want to use an actual request. I don't know how to call it yet, probably quiz status request. And let the request contains the user token. The response would be the same, but the request does not exist yet. We'll fix it. We need both quiz code and the user token. That's it. We should probably check if the user belongs to the quiz. Not so sure if it's necessary, but still. And we are returning the user quiz state. So far, nothing thrilling, but, oh, sorry, again, I was updating the wrong method. I should copy paste all the data. That's not the best way to compose a new method, but still. This is just a pen test. This is not a production-ready project. I'm not updating the quiz state imperatively. I should do it somewhere else, transparently for the quiz manager. I'm not setting the state, I'm just returning the state. But I don't like the fact that I'm not checking the quiz state and I can return the quiz state is scheduled, even though a couple minutes passed already and the quiz should be started. Probably I should introduce one more level here inside of the state repository that just reads values from Redis and set values into Redis by some provided keys. Instead, I will implement a state manager or state update manager that would read the quiz state and update it transparently for the calling code. Next to the quiz manager, I'll probably introduce quiz state update manager, new Python module, and this class would rely on Redis as well. And would have an initialization method. I might not create this quiz state repository I'm using in the quiz manager because I don't want to create two repositories. Instead, I will rely on this as an argument. Let it be an internal variable or hidden variable. Okay. I want to implement a method that returns a quiz state, but also updates the quiz state if needed. And to read the quiz state, I only need the quiz code. Let's not decide here if the user is authorized to get this quiz status, if it belongs to the quiz players list. I'm returning the same data I would return from the repository. Quiz state repository returns this tuple. I should import all the classes here, starting from tuple type definition, the quiz state, and the quiz players. Now, how do I get the values? Before updating them, I would use my state repository, and I would just read quiz state. And for this, I need just the quiz code. Okay, I want to unwrap this into a quiz state and players. Now let me update the quiz state. I don't have this method so far. Maybe I have to update quiz players as well. Okay, I'm not so sure. Should I update players? So far, there is no runtime data in the players. Instead, what we know about the players by the moment the quiz started. And after updating the state, I may simply return this data. But what about the actual updating logic? First and foremost, I need the current time to decide should I start the quiz, should I finish the quiz, or should I move on to the next answer, to the next question. Where do I get time already? Current time in the quiz manager. I have it here. I have it here. Let it be time. Should import this. And now it depends on the status the quiz resides in. And for now, we implemented dependent status. And dependent status should be updated. For something else, I'm not so sure. We might expire quiz. Should we expire quiz? Probably that's not a big deal because the data will be automatically eliminated in Redis. We specify the time to live for the quiz data. But still, let's check the quiz expiration time. Is it expiration? Is it daytime? Yeah. If it's still not expired, yeah, let's check the quiz status first. If it's pending, no. There is no type hint, unfortunately. If it's pending, so if it's not expired yet, we could at least update one field of the quiz itself. And this field is updates in seconds. This is the difference between the expiration time and the current time. And this difference we calculate in seconds, but I want to round this value. I'm not sure about rounding. Maybe I should floor this value or sell this value. Not so sure, but let it be math round so far. No, because round does not belong to math. Yes. Again, I don't wanna introduce more complexity here. I don't wanna move this pending state next to the expired state because quiz will expire automatically. All the data will just be deleted from Redis. That's why there is nothing I'm gonna check now for the pending state. I will return, but I'm mostly interested in the scheduled state. Because I want to run this quiz automatically. Again, I'm checking the starting time. Not again, because previously I was checking the expiration time. And if quiz hasn't started already, I will just update the existing updates in second time. Now I see there could be a little problem with rounding. Let's say our network is light speed, and I'm rounding the time that equals to 3.5 seconds. I'm rounding the time up to 4 seconds. No. In this case, it would be 4 seconds. That's okay. But if the time is 3.4, it will be rounded down to 3 seconds. And our client would expect that the quiz would be started in 3 seconds. And exactly in 3 seconds, our client using its Lightspeed internet connection will ask the backend for the quiz status update. But the quiz status is not updated yet, and the response would be still scheduled. So the client should ask one more time. Instead, I want to round the value up or seal the value. Now I need math. Surprisingly, round does not belong to the math, but seal does. And in this case, again, 3.4 seconds left. It would be sealed up to 4 seconds. And in 4 seconds, with guarantee, the quiz should be started already. Otherwise, if the quiz starts at the time or even before, so the time came, we should update the quiz status. It started. And we should update this quiz status in Redis as well. Let me use the same state repository to set the quiz state. And the quiz state is here. We already changed it. Now the expiration seconds. We have the quiz constants. And in the quiz constants, we have the started quiz expiration seconds. Previous value was pending quiz expiration seconds. It was probably lower than this value. So we'll preserve this data for a bit longer, maybe for an hour, not for 10 minutes like we did before. So for now, for the scheduled quiz, this would be enough, but let me add a bit of to do here. Let's check and update if required the state of the running quiz, because we might finish the running quiz and we might also move on to the next question if the quiz is already running. But for now, we do nothing because we haven't yet decided on the logic for the running quiz. We don't have corresponding queries. I only want to check if the quiz could be promoted automatically from scheduled to started state. But now I'm going to introduce this quiz state update manager here in the quiz manager. And let it be self, probably quiz state manager equals to this class initialized with the state repository. Maybe just state update manager. And each time I'm reading the quiz state, I want to use this manager instead to be able to update the quiz automatically. And let's see where are we using this. State repository, set state, that's okay. Set quiz place, again, okay. But here, while joining the quiz, we might actually read and update the quiz state. But again, we'll get this quiz state and quiz players. Setting is okay, but reading we are changing for the new repository state manager. And of course, while getting the quiz state, we'll do update as well. Now I want to test this, and I want to test that the quiz is automatically transferred from the pending to scheduled, not automatically by the user start request, and then automatically to the started state. I want to go and check if the quiz starts automatically after being scheduled. I start from copy pasting as I always do, but now the test is test quiz started automatically. And I will start the quiz. I'm gonna check the quiz status code only. But now I wanna update uh, the quiz state automatically and check if it's updated. I wanna wait for, let's say, a couple seconds. Let it be 3 or 2.1. And then request the quiz status again and check the state. Let me check the quiz API. Do I have this method already of checking the quiz? Oh, actually I have couple troubles here. First, it shouldn't be join quiz, but schedule quiz. And second, here I don't have a method to request the quiz state. Okay, get quiz state. Let me check what I have in the quiz manager. And I need the quiz status request. and it would be quiz get state probably. I'm not so sure if this name works for me, but it will do for now. Or maybe quiz check status. So I'm trying this endpoint in my quiz schedule test. And the payload is different. Slightly different, I would say. Because it's the same except for the delay seconds that we don't need. And after sleeping for 2.1 seconds, we'll expect the quiz status is started. Let's see if it works. Yes, fine. I'm not happy about this time sleep because we'll be having more scenarios when we have to sleep couple seconds or maybe more. Say if the quiz has to be started, if the quiz has to be finished, and the quiz contains couple questions and the interval between questions is 1 second, we should wait overall 3 or 4 point something seconds for the quiz to be finished. But I don't want to make our tests wait extra time. Instead, I have an alternative. And this alternative is called freeze gun. What I'm going to do, I'm going to replace this actual sleep interval with some changes with mocking the system time. Python accesses system time through some special system methods, and by mocking this system method or system function, we can make Python believe that much time passed since the present moment. For instance, that now we live in the year 2018, the year before the pandemic. It would be nice to live at that period, and I want to use this freezegun library, but let me refresh my memory on the library syntax. It's Python, freezegun, and to use the freezegun, I'm actually gonna install it as a package, but after installing, I will be using this extra decorator. Let me install the package. The packages are upgraded. I want to import something. Probably I'm missing this. Let me check. How do I import the freeze time? Maybe I should wait a bit. No. Okay. Now should be fine. That doesn't matter. The specific date doesn't matter much. What matters is the specific time, including milliseconds. So let it be 10 a.m. But nothing should happen so far because I'm only shifting and pinning my test to the specific time. What I actually need to shift 2 seconds forward in time here. And how do I do this? I should check the documentation inside the code, not as a decorator for the whole method, but something, yeah, like here. I'm gonna shift time 2.1 seconds forward, and this means I'm copying and pasting this, but these are seconds, 2.1. Nice. The test passed, so that means I don't have to wait 2 extra seconds. Let me check if I wait 1 second only. 1.1. Oh, I'm not so happy about this. Something went wrong because the quiz was scheduled, but immediately it was updated to the started state. Okay, let me wait for virtually 200 milliseconds. I'm gonna debug this. I'm gonna go to the quiz state manager, and here I'm updating the quiz state. The quiz state is pending, and if it's only scheduled, I should run this line. So let me put a breakpoint here and debug this test. Actually, I haven't debugged this path. I didn't get there. I should go back to my quiz state quiz manager and check if I'm changing the quiz state directly to started somewhere. No, I'm not. I'm only scheduling the quiz, but the quiz state got automatically promoted to the started state. For what reason? For now, it's a mystery for me. Let me clarify this. Again, when I just started the quiz, the response code is scheduled. And now the response contains a state, and the state is actually scheduled. Oh yeah, my typo. Instead of comparing, I'm just making it equals to something. And I need an assertion. Let me move time 2 seconds forward. No, no, it's not getting updated. Oh, it's a key error. It's not the status code, but what is it? Let me improve my unit test a bit. I'm debugging the wrong method, now the right one. This response JSON state, I should check the status variable, okay, not the status code. Now that's okay, but if I don't move time 2 seconds forward, but just 1 second, is it still started? No, it's not. It's still scheduled. And that's what we expected. Let's fix the test and let's check the whole tests in the quiz we defined so far. Nothing's broken. Let's check how far did we get, and I hope we implemented more than a half of the required requests. And actually, we have quiz topics, quiz start, quiz join, check status. What's left? Answering the quiz. Probably the last, but the most tricky part. Not sure about how tricky it is. Let's see. We go back to the quiz manager and we'll implement this plus minus the same way we used to implement other quiz comments before. Like for scheduling the quiz, we need the quiz state and we should update it immediately. if the update is needed. And we need to check if the current user actually belongs to the quiz players list. And we should be using this quiz token to provide the user's answers and to store the answers in the quiz player state. Not so sure where to store it because so far we didn't have answers anywhere stored for the user. We'll fix it soon. As always, I'm copy pasting, but now it would be store answer. And this request, of course, it's different. It's not a schedule quiz request, but again, it's a pydantic data class JSON decorated class. The request is simple. Let it be store answer request. And actually, we again need the quiz code and the user token, but we also need the question, the answer data. And the answer, let's see what we have for the questions. Each question is some text, some image. The provided answers as a list of strings, and the correct answer is probably this guy is a list, and this is a scalar, but again, it's a list. So even if the question is single choice, the answer should be a list of one item. Going back, here the answer is a list of integers. Later on, we compare the answer with what we expected. And again, just in case the user, the GUI believes it answers a different questions, it answers question number 2, but this is the question number 1 that should be answered, or maybe it's time already to answer question number 4, but we are still answering question number 2. They could be collision, and we'll at least detect this collision if the user will provide the question index. The user believes he is answering question number 2. It could be something else. We'll check. The quiz manager, where do we have it? Store answer request. The response is again user quiz state. Now, what we do after we get the current user? First, we probably check the answer time, the current time. We might need it later on. I'm not so sure, but I still believe that we should store this time, the time that the user answered the question. Because, for instance, if multiple users answered the same question and all of the users were right, we should define who was the first to answer. And the first user to answer the question is the winner, at least in the scope of this question. We might do multiple things here, going to Redis, doing some extra stuff, but before we'll store the answer time. And now we check if the quiz already started. We could do it before, even before checking the users. If it's not started yet, we'll raise an exception that the quiz we obtained by the quiz code from the request hasn't started yet, or it might be finished already. So it's in the queue underscore state status. Most probably it's pending, scheduled, or something else finished. So now we are checking the current quiz state, current index question. We have to update this current index question, and we'll update the current index question here. The state update manager would do it transparently for our quiz manager. It doesn't do this so far. Let's check. If we do update the current quiz question, no. We just update the quiz state from scheduled to started. We'll do it a bit later. Let's assume we do update the current question. So we should check if the request data current quiz question index actually equals to the quiz state current question index. Where is it? Ah, yeah. It's a tuple. And the first value is the question index, and the second is the total amount of question in the quiz. So if they are not equal, again, what we do, we raise an exception. The exception says exactly what we mean. The current question index is different, but let's display to the user what the GUI believes the current question index is, but actually it's something else. Okay. But the current quiz question is this. Or we might display the whole tuple, both the question index and the amount of questions inside the quiz. And now we're going to store the user answer. So far, we haven't defined a storage for the user answers. So we have already a couple to-dos. One of the to-dos is to update the quiz state, update the current question. It's missing. Let me, yep, I checked, we have this to-do. But also we have to define somewhere the quiz answers for each player. Apparently, we should define the quiz answers here in each quiz player's data. But what is the quiz player's data? It's here, quiz player. We need answers here. And the answers is a list of lists of integers. Might be. Let's check. Okay, we are storing the answer time. And answer time, we need to define who was the first answering this question. He would be the leader of the round, providing several players gave the correct answer simultaneously. So I want to introduce one more class here, and the class is quiz player answer. It's an answer, the list of integers, and answer seconds. It might be a floating type, it might be an integer type as well, because this is not about precision. Because requests might come half a second later with latency of tens, hundreds of milliseconds. So let's round it and answer given seconds. If it's given, is a positive value. If it's not, it's just -1. We have the answer, and now our answers for the user is a collection of quiz player answer. That's fine, we should utilize this structure somewhere here. Let's go back to the user. Hmm. Now we might face another error while creating the quiz player record. Yes, we need to actually pass this value, answers. Let's check this small, tiny, little yellow mark on the right side, and it shows us again the same problem. Answers are not provided as an argument, but now it does. We do have answers, and we can store one. So what do we do for the current player? And we have the current player here. It's only one item because we are not supposed to have multiple users with the same token in the quiz players list. On the list, there is only one item, and this one user should have these answers initialized with some values. Now I have to set up a specific answer by its identifier. Request data question index is the index of the answer. There might be a problem because this array is initially, this list is initially empty, but we'll fix it soon. We just have to provide the quiz player answer. So what's inside the answer itself? This comes in request. And the answer time, but actually I want to store the amount of seconds passed since the question was presented to all the players. How do I calculate this? I want to know how much time passed since the quiz started. And this total amount of time, seconds since started, equals to current time or answer time minus the quiz start time. Starts at in seconds. But for instance, if I have 10 questions, but between each two adjacent questions, the time interval is 5 seconds. 12 seconds passed since the quiz started. This means the current question is number 3 or index is 2. So how much time has passed since the quiz started? Let's check it in the Python console. Let's say seconds since started equals to 12.4. And let's say the question seconds interval equals to 5. Now, if I get the remnant of the division from the seconds since started value to question seconds, this is 2.4. This is actually the third question that should be displayed. So how do I deal with this time? How do I calculate how much time has passed since this question? Let me check. I'll use my drawing tool and I draw a line, this timeline, and I'll place here an indicator. Let it be 10:00:01. This is the time the quiz started. And it's now time, 12 seconds passed. Now it's 13. But when do we expect the first, the second, the third, and so on questions? This is the moment our quiz actually started. And presently, the question we display is number 1. But the interval is 5 seconds. So in 5 seconds, we'll display the question number 2. Five more seconds, and we are displaying the question number 3. 5 more seconds, question number 4. What should we determine? Let me show it. This interval of time is the time that passed since the user answered the question. Since the question was published and the user answers the question. So what's the time we start displaying question number 3? Let's calculate. It's 5 plus 5 plus 10:00:01. This means 10 hours, 0 minutes, 11 seconds. The time the user answered, the time that demanded for the user answering the question number 3 is 13 minus 1 and minus 5 multiplied 2. Or actually, it's a remnant of division the whole interval between these two triangles by this part, the interval between these two questions. So this value and this value means seconds since started. We divide by this value, and this means question interval. How do you call it? Question seconds. And this yellow interval is the remnant of the division. And we'll probably round this remnant to the right or to the left side, depending on the amount of milliseconds. So I believe our calculation is good here. I use this calculation. Later on, I may fix it. But for now, the time passed since the question was published is a rounded value of this. Seconds since started. We should delay by the interval between two quiz questions. We should store it somewhere. But not the division, the remnant of the division. And this time we store here. Now that we updated the user answers, we should as well update the user state. We already have it in the user repository. Sorry, in the state repository, we have the method to update the quiz players data. And to update the quiz players data, we need the quiz code first. It's here in the request data. And we need the players data. We have it. Just quiz players. Yes, just quiz players. And now the expiration period. I'm not sure what to provide here because actually some time passed already since the quiz started, but I believe there is nothing wrong in providing the same value, started quiz expiration second. We will update a bit quiz, state, record, time to life, but time to live, that's okay. I'm completely okay with it. The only purpose of this field here, of this TTL, just to preserve the quiz data for a bit longer and then delete it eventually. I'm store the updated answers for this particular user, and now all I need is to return the state, as I did previously. I'm using these lines of code throughout the whole quiz manager implementation. Probably later on I'll refactor this code. But for now, I believe we are almost good, almost, to test this method. Why I'm saying almost? Because let's check again our state update manager. We are reading and updating the quiz state. And if the quiz is scheduled, we are making the quiz start. But we are not updating the state of the started quiz. And we are not updating the quiz current question index. Plus, there is one more weakness, one more flaw that we definitely should fix. And this is a flaw. We are updating the specific answer, kinda assuming that the answers list is not empty. We can just change the specific value, say value number 2, but the previous one value might not exist by the moment we are executing this line of code. This is a problem we're also going to fix. This is actually easy to fix. Maybe before answering the question, we'll check how many answers are already here, or if you have any answers here. And if not, we'll initialize the array with empty answers. So this would be the quiz player answer and the answer arguments are default ones. What else is expected? Answer given seconds. But actually, we don't need this value because it's defaulted to -1. We would multiply this array n times, and the n equals to the amount of questions in the quiz. How do we know how many questions are in the quiz? Let's say the quiz state, current question index, second value is actual amount the questions in the quiz. So far, we used to have here 0 because our quiz wasn't started yet, wasn't actually started. And we haven't calculated the amount of questions in the quiz. We haven't calculated the number of the current question, but we'll do it soon. We would rely on the update manager to update the quiz state and to update this value as well. Alternatively, we could read the quiz list here, quizzes, get the one corresponding to the quiz topic that we have in the quiz state by ID, and get the number of questions in this quiz topic. But for simplicity, I would use this value. Now it's time to update our state update manager and introduce quiz state update for the running quiz here. What we're going to do now is to implement this method, and this would be a private one. We'll be checking and updating. running quiz. And we need the state to update. Let it be Q state. We don't want to return the state. Inside we update these variable values. But it's about running quizzes only. So if it's not running, if quiz state not equals to started, we'll just return. Now that we know the quiz has started, we should calculate the current question index. But before, I want to know how many questions do we have. If we haven't calculated the current question index so far, we cannot rely on this current question index second value. Instead, we should get the quiz itself. But we don't get the quiz here. We need this metadata, and we are missing this metadata. So, like in the quiz manager, I would prefer having this quizzes list in the update manager. Let me pass it as a second argument to the constructor and let it equal to quizzes. Now we have quizzes. We have to pass them. We can get the quiz by its identifier. Let it be quiz data. But only if this current object identifier equals to quiz state identifier. And we need the first element. Now again we are calculating how much time passed since we started the quiz, like we did in the quiz manager before. Where did we do this calculation? Second since started. That's not the answer time, but now time. Okay. What's the question index? Now it's simpler. If we go back to this drawing, the question index is actually float amount of time divided by the interval between two questions. And if 12 seconds passed and the interval is 5 seconds, 12 divided by 5 is 2.4, but they don't need this 0.4. For us, this would be just 2. So we should divide, let's see, second since started, divide by interval between questions, and we are flooring the value. And this is a question index. Fine. Now we want to know how much time is left for answering the next question or for finishing the quiz. If the quiz is not finished yet, we want to define this a bit later. Let's see. We know the interval between two questions is, say, 5 seconds, but we also know how to calculate this interval. We did it before. So this interval before displaying the next question, we have this value here in quiz state. This updates in seconds. This means the quiz updates in, say, 2.6 seconds. It actually equals the interval between two questions, this one, minus time since the question was published. And let me check, where did we calculate this time? Here. But should it be round or something else? Because I wanna make my estimation a bit higher when it is actually, because next time the user comes for the quiz state, the state should already has been updated. Otherwise, the user would get the previous state, the current state, and would repeat his request until the state updated. So if I want to display the bigger value, the right part that I'm rounding should be a lower value. So I'm doing math floor. Do I have math here? Yeah, I do. Nice. And now the question index might be outside the bounds of the quiz questions. And if the question index is outside, where did I get this amount of questions? I'm going to do something. I'm going to finish the quiz. Otherwise, I'll update the quiz state. Before updating the quiz state, I should check whether I should update this quiz state. Is the index actually updated? Because it could be equal to what we have already in cache. And this way, I don't want to go in Redis cache an extra time and update the value if the value again hasn't changed yet. So only if the queue state current question index, the first part, the question index itself, is not equal to the question index, I do my updates. What I do is, again, current question index is now this, the combination of the question index and the amount of questions in the quiz. Also, I have to display the question. If we go back, here I'm displaying the state, and I have this question in the state. I want to return this question to the user, to all the users. The users will display what they get in the response to the get quiz state request, or maybe after publishing the answer. After publishing the answer, or after getting the quiz state through a get request, the user will display this data. So I'm probably missing something in the quiz state. Let me see what I have in the quiz state, apart from current question index. I have current question, but the current question is actually a string, an optional string. I'm not sure if it's a string. Let me check what I have in the quiz data, what the question is in the quiz data. And actually, the quiz data question is a class, including all this detail. So I want to go back again to the quiz state definition, yes, and replace my question with this. So far, I'm okay with the current question because I haven't used it before in the quiz manager. We didn't get this far. We were only using the current question index, not the question itself. But now it's all about the question. So current question. Why it's not displayed? Let me check. Yes, it's here. Is a quiz question, but let's see if it's okay for us to publish the question itself from the quiz state. It's all about questions. Where do I have questions? No, it's all from the quiz data. Questions and question index. Quiz question includes not only the image, text, and answers, but correct answers as well. And I don't want to propagate the correct answers to the user because the user could just get to the browser console and check the payload. And here on the network tab, he'll get all the answers. I don't want to provide the ability for the user to cheat as easy as this. So I'm gonna remove the correct answers value from the question. Here, I'm gonna do this. I'm gonna take my current question and current question, correct answers should be an empty list. But now here comes the problem. And the problem is I don't want to modify for now the quiz data questions. Still, I believe my quiz manager is an ephemeral object. We don't preserve its state any longer, only for as long as it's needed for uh, processing the current quiz question, to start the quiz, to perform any action with the quiz. So we'll create this object for processing one user request. But anyway, we may go with some changes further. We might update this code, we might update this logic, and we might need this quiz data questions data untouched. That's why I want to copy this data and I want to deep copy this data. And for deep copy, there is library copy, deep copy. Could I just import this? Yes, I do. Now, this answer, this current question, sorry, this object is not the original object of the quiz data. And now that I'm updating the correct answers for the current question, I'm not updating this one. Let me illustrate this in the Python console. Let me have an object, dictionary, and let me say b equals a, and b value of the key equals to n would be 10. Here on the right side, we'll see that both variables has n equals to 10. But now I'm going to redefine b, and b is copy, deep copy, a. Now I'm going to redefine b again. It should be something else, 20. And let's check what's inside A. A is untouched. I'm okay with the answers. I removed them from the question. And now I should update my state repository with the current question index updated and the question data updated as well. So somewhere here I have the state repository. And I'm setting state, and that's the quiz state. And what's the interval? It's from the quiz constant. Constant started, yes, started quiz expiration seconds. That's it, except we haven't defined this finish quiz method yet. I don't want to implement it right now because I want to test. Right now, I want to test instead the logic of the quiz in progress. So let it be non-implemented one. But as soon as I have this check and update in the quiz manager, in the quiz state manager code, I will be able to test more complex scenarios. Like the quiz is in progress, the current question is updated, we have the current question text, image, and we have the current question index. And we could answer the current question. We don't need this to do. That's nice. Before checking the new functionality store answer, I should add this functionality to the API of the quiz. I don't have it yet, but that's easy to fix. Quiz, it would be store answer. The endpoint is probably just quiz answer. The request is different. But even before testing this new method, I want to test the existing one for one more case, and this is the quiz schedule. I want to check that after a certain amount of time, our quiz current question is updated. But the quiz current question should be updated right here. So now I'm not only checking this state status, but let me check what else could I compare the status, the state against. I should have somewhere the current question and the current question index. Okay, state. Let me go back to the quiz state definition, current question index. Should be equal to, I'm not sure. It's probably list or tuple. I'm not sure about how to deserialize this value. Let it be the list, and the current question index is 0 because only 2 seconds passed, and the delay interval for our scale request was 2 seconds again. And the total amount of questions, we have 2 quizzes with 2 questions in each. So it should be 0 and 2. Fine. This value was actually deserialized as a list because I'm not sure about this deserialization logic being able to deserialize a tuple, but I'm fine with the list. And I want to check the actual question. It would be current question. And what's inside the question? image, text, and answers. Text should not be empty and answers should not be empty as well. Let's check what inside answers. I don't want to go and check the quiz, but probably there are 3 answers. Current question. Answers, yes, there are 3 answers. And I could check the length of this field, and it should be equal to 3. Nice. But what about I will move time forward couple more seconds, or what's the delay interval for the quiz? I should go here and check. The question seconds is 13. So I want to move 13 seconds more. And of course the status is started, but the question index should be 1 and 2. And I am not sure about the answers. I should probably this time check something more specific. I want to check that the correct answer is empty and the number of answers is 4. Let me check the correct answer. No, something went wrong. Correct answer is missing completely. Interesting. That's okay for me if I don't have the correct answer in the response, because I want to hide this value. I'm just not sure why it's not correct answers, plural. Let me check it one more time for the next question. Fine. We see that the quiz status was updated and the question index was updated and the question itself was updated. The first one contained 3 answers and the second one 4 answers. But the only thing missing is the completion procedure for the quiz. Because when the time's over, we should finalize the quiz and we should calculate the current quiz result, the winner of the quiz, and the ranks for the rest of the users. But this is completely different story. We should go back to our quiz manager and analyze. Probably we need to introduce one more class, one more entity to represent the quiz results. I haven't checked yet the new method of giving the answer for the quiz. I'm going to implement this test almost the same way I am testing the quiz schedule method. Copy, paste, test quiz give answer. I want to start the quiz, then schedule the quiz. Then after scheduling the quiz, I will wait a bit, and after a while, I'll provide the answer to the first question. The endpoint is slightly different. It's quiz answer. By the way, I don't need the response for the previous request, do I? No. And the request is definitely not a quiz status request, but store answer request. Again, there is quiz code and the user token, and also the answer and the question index. Question index is 0. Answer is second option. I want to check that the quiz started. I haven't checked the quiz state before. The quiz state should be updated upon my request for posting the answer to the server. And I want to check also that current the question index is 0. But that's not all I'm going to check. I'm going to check the user state. I haven't decided yet what I'm checking. Let me remove this. Inside my user array or dictionary, I will have more detail concerning the answer I just provided through this request. So I would update the name of the test give answer, and run it. No, it wasn't a success. For what reason? Quiz in the started status. Oh, that's interesting, because the quiz is in the started status. Still it says it's not started yet. Let's check. What's the quiz state? Actually, I'm not checking the quiz state status. Let's go back and run the test again. Still no luck. Interesting. I haven't provided the answers for the quiz player. Let me check what was happening here. I have a guess. The quiz question index second dimension is empty, is 0. But let me check it, debug, and go up to this line of code. Current users index is 0. And what's inside? The answers are empty. Yes, it's okay for now. And what's inside the current question index? It's actually okay. So answers. Oh, I pressed the wrong button. Let me run the test again. I want to. Oh, that's interesting. Actually, I should have checked that the answers are empty. So I'm going back to the quiz test, run it again, and it passed. But I want to check now what's inside the user data. Do we have this answer provided? Let's see the response JSON user answers. We need this array to check. And we need to check the first answer, index is 0. And the answer, the answer is actually the list with only the item 2. And I'm also checking that the answer given second, how do you call it? Answer given seconds. That's the answer, and that's a seconds equals to 0 because extra 200 milliseconds passed since we started sharing this question. Let me run this code again. No. Dictionary object, yes, that's not an object. That's not a variable. That's not a class member. Instead, this is just another dimension of this dictionary, if I could call it dimension, another key. Yes, that's it. And I want to repeat this. I want to provide the very same answer for the very same question, but a bit later. Let's say 4.2 seconds after the quiz started. I mean 2.4 seconds after the quiz started. So I would expect here 2 seconds. And the answer should be the same. I'm not checking any longer this data. Let me check now. Everything's fine. Finally, I'm providing the answer to the third question. Oh, sorry, to the second question. And the time should be 2 plus 13. It should be 15. And the question index is now 1. The answer, I will have it here, 0 and 1. I expect this answer here. I'm not sure about answer given second, probably 0. Let me run the test again. No. Believe some of the assertions failed. Oh, interesting. Current question index is 0. Yes, I forgot this part. I forgot to update current question index while I was answering the second question. This could happen to the client. If the client lost his track of time and he believed he was answering the second question, or the first question, but actually it's time to answer the second. There should be an indication of this, and the exception is a good indication. Might be not so good because it wasn't propagated up to the body of the response. We'll fix it later, but now we'll run the test. And again, something is not that we expected. Yes, because I'm checking the second answer now, not the first one. Finally, everything's fine. Now I'm going to focus on finalizing the quiz and calculating the quiz results, and finally returning the quiz results to the user in a separate request, that resembles the existing one for getting the current quiz state. Might be we'll extend this request to return the quiz result in the quiz state, or might be we'll implement a different request to query the actual quiz results when the quiz finishes. But before we should decide on the results, on the format, and for now I'll place results here, but I might change my mind in future. It would be quiz results. I want to go back to my board and check what we have in the results. And we have player ranks with the number of the questions they gave correct answers, the total amount of questions, the rank of the player is on the left, and for the current player, we'll render the player's answers. The answers for each of the questions. This should be easy. The answers are just lists of the options the user selected and the time required to answer this very question. So let's go back to our class quiz result definition. I believe the quiz result should anyway contain the quiz ID. Might be, not so sure. And the quiz name. We want to render this result on a separate page. At least we want to have this option. And I should know what was the quiz, what was the name of the quiz. I might query extra data for the quiz, and for this I need the quiz identifier. I want to also know at what particular time the quiz started. It's not an optional any longer, and it's not starts at, but started at. What else do I have in results is the player results, the players. And this is something we haven't defined yet. Probably this is just a list of the specific player results. And I will define this data structure, this class here. Quiz results player. That doesn't sound good, but again, we can rename it later. And the player has a name. That's important. And also he has a number of correct answers. What else does the player have? Probably the total amount of time he spent answering the questions might be. We might have it here. It might be a floating point value. I'm not so sure about it. Because so far we used to have integer values. Let it be integer as well. And the answers. And for the answers, we already have the class defined quiz player answer. It's all about the options the user selected and the amount of time the user spent answering the questions. So answers is as simple as the list of the quiz player's answer. Yeah, that's it. I believe we may use this data here. And now we have defined the results we should return to the user, but the most important thing is the quiz state update manager. And let's see, yes, we have not implemented error here. We should finalize the quiz if the time's over. And calculate the results and probably store the results. And in the Redis as well, in the database, we might replace Redis with something else. We may have instead of Redis DynamoDB or a relational database. But anyway, we want to store the results probably using this state repository. But before, let's decide on finalizing the quiz. And let's implement this method. We'll start with checking the quiz state. It should not be finished, because might be this calculation is already done. And I don't want to repeat this process, because it might be a bit costly. So quiz status code should not be finished. If it's finished, we do nothing. Otherwise, oh, sorry, I need the status here. Otherwise, I'll update the status and let it be finished. And now I wanna rank all the players by their answers. But before this, I need couple more steps. First, I need to get the quiz data. I'll be comparing the answers the players provided with the correct answers we have in the quiz data. It's here. What else do I need? The players. We'll read the player data, including the player answer, from their repository. We don't need the whole quiz state. We already have the quiz state. We only need the quiz players. Let me define this. And I'm copy pasting again. but returning just the quiz players. But still I need the quiz code. And I can reuse this simple code here for not to repeat myself. And the quiz code I provide. That's it. Where is the quiz code? It's here in the quiz state. I got the players. I might optimize this in future because probably here where I finalize in the quiz, I have the players as well. I'm having this queue state. No, I don't have quiz players. Probably here where I'm calling this function, this method, I have players as well, but I don't want to pass the players there. It's a cheap and fast operation to request the player state. It might be even sub-millisecond, not sure about the Redis performance for Elastic Cache in AWS, but still it's fast and cheap. I may optimize this in future, but for now I got the players from Redis. And as soon as get the players, I would probably go through the quiz questions and check the correct answers with the answers provided by the players. Let's implement this simple loop. I need the quiz question and the index of the question. So I'm going to iterate the questions. Or how do I do this? No, I want to enumerate the questions. So let's go back to the quiz data, and the quiz data contains answers and correct answer. Correct answer might be a list. I'll be comparing lists, but what if the user provides values this way? Comparing two unordered lists is a bit tricky task, so the first thing I do, I'm gonna sort the answers, the correct ones. It would be sorted, question, correct answers. Fine. Now I'm gonna go through the players the same way I do this for the questions. Let me not make this silly mistake. I could have introduced the same counter variable here, but I did it differently. This is player index and the player itself. In again, enumerate players, players. The good thing about the players' answers, let's check it. We initialize answers with some predefined values, with empty answers. As soon as the player starts answering, we populate the player's answers with some values, with default values. The answer is an empty list and the question index is, the time that the user spent answering this question is -1, the default one. So we'll always have all the answers, the same amount as we have in the quiz, except for the case when the player never answered any question of the quiz. And I want to check and skip for this case if the current question index is out of bounds of the player answers. We'll probably do nothing. Otherwise, we'll calculate some score for this player. How do we calculate the score? We probably should accumulate the score value for all the quiz players, and this score would be as high as the player rate of the answers, of the correct answers, and should be not so high if the player was the slowest answering the question. So we should calculate both factors, the correctness and the time elapsed, the time spent answering the questions. But before this, we should define some value. I will call it player scores probably, to accumulate the scores and to update the scores here. Player score for each player has two dimensions, and the first dimension is, of course, the number of the correct answers. But the second dimension is the amount of time spent answering the questions. We could easily calculate the amount of time because we have this amount in each and every question. But on the other hand, we should probably summarize somehow this amount of time spent and the amount of correct answers, and the amount of the correct answers is the one that determines the winner. But if there are multiple players with the same score, we should pay attention to the time they spend answering questions. So as we have two dimensions here, we'll have a list with the same amount of elements, items as we have in the players list of tuples, and these tuples are of type oh, integer and probably float. I can't remember now, is it float or integer value or the amount of time spent? Let it be integer and float. It's not a big deal, I believe. And again, we'll be starting from some default value, tuple, that will multiply this time 10 players, 10 player scores. And each score for now has a default value. We'll be replacing values soon. But now I want to get the current player score, and I get it by the player index. And I'll update the score. But before updating the score, I'll be using the player answers. I'll do the same that I did for the quiz answers. I will sort player answers. Here is my player. And I need the particular answer on the question, for instance, the index 0, 1, and so on. So the index is I. But the answer itself, what it is, okay, we need this list. So I'm sorting the answer variable with type of list of integer. How do we check if the answer is correct? As simple as this. We are checking the sorted answers against the player answers. For people with the background that is not Pythonic, that might be a trigger. So we are checking two lists, and we could potentially compare some memory pointers, but not the list content itself. Let's check how Python works when we compare two lists. Let's say R is 10, then 2, and B is 11 and 2. Of course, R is not equal to B. A is not equal to B, false. But let's say B equals to the same value, 10, then 2. And what if we check again? It's true. So we're comparing the list by values. In this case, we'll increment the score. The first element of the score, the first item, is actually the amount of the correct answers. So we'll increment the score this way. Score equals to the previous value for the first dimension. And the second dimension we increment by the amount of time the user spent answering the question. Let it be second dimension plus player answers, answer given second. But if you go back to this variable definition, it could be -1 or minus something if the user skipped the question. So I wanna replace this value with something else, with the total amount of seconds between the two questions. Where do we get this? In the quiz state itself. Let's say it took players some seconds to answer the question. And the player answering time, it's this. If only this is greater than 0. But let me state it another way to simplify the logic. If it's less than 0, then player answering time equals to quiz state question seconds. Fine. And we'll store this player score. Probably I'll simplify this a bit. I'll be incrementing the second dimension of the score each time. But this time, if the player gave the correct answer for this question, I will just update the first dimension, the number of the correct answers. And the second dimension, I will update regarding the player answer, the correctness of the player answer. So I updated the score one more time. And now I'm going to save the score in the player scores. That's fine. But now I want to sort the player scores. I need to sort this array based on this score, based on first this dimension, and second, if the number of the correct answers is the same for several players, I would check the second dimension, the amount of time they required for answering all the questions. But before, I wanna extend this list a bit. Now this list is just tuples, and the position in the list is the player index. But as soon as I update, as I sort this list, I will lose the position of all the players. And I can decide on which player occupies which positions on this list if I sort this list. So I need the player scores with indices. And how do I do this? Again, list comprehension for let's say E and score in this list, but I enumerate this list for getting indexes and scores. And what I'm storing is I and score. Now I had a list. Now I have a list of integers representing the player index and tuples representing the amount of time spent and the number of correct questions, the amount of the correct questions. Now I can sort this list. And the key I want to sort is the lambda. And I'm sorting first on the first item. Okay, what is the item? The lambda argument is item, and the return value, the value that the lambda returns, is the item first element. Now the player score index contains the index first and the score second, and the score is a tuple. So I need the score. This is item second dimension. And first, I'm going to check the number of the correct answers. But if it's the same, I'm going to check the number of the amount of seconds that the player required to answer all the questions. And it would be a reversed order because the best player with the biggest amount of the correct answers is the first player, is the winner. But there is a problem about the second dimension. The first dimension is simple. The bigger the better. The bigger the number, the higher the player position. But this is quite the opposite for the second dimension. So I will just negate this. And I believe I'm good here, but in case I'm not so sure about how this sort works, let me test it in Python console. Let me create a list. And the list would be a list of tuples. Say the first one contains index 0 and 4 correct answers. And it took the player 12 seconds to answer all these questions. The second index is 1, 3 correct questions, but it took only 8 seconds. And finally, the last index is 2, and the number of correct answers is 5, and it took the player 15 seconds. So after sorting this list of tuples that has the same structure as this very list player score index, we expect that the first item, that the winner is this player because he has the most amount of the correct answers. The second is this guy, and the third is this guy. Or actually, let us provide one more player with the same amount of the correct answers. The index is 3, the correct answers is 4, but for this player, it took only 11 seconds to answer all the questions. So the second after the winner should go this player with index equals to 3. Now this guy with index 0. And finally this guy with index 1. Let's see how it works if I apply the same sorting function. Now here is the winner with 5 correct answers. And the second is the player with index 3 because he gave 4 correct answers, but it took him only 11 seconds to answer all the questions. The third guy has also 4 correct answers, but it took him 12 seconds. And the last one is the player with 3 correct answers. That's good. Now I truly believe we have everything to finalize the quiz and to compose the quiz results and to store the quiz results somewhere. So I'm defining the results. Finally, the results are the quiz results. No, we haven't imported yet. And for the quiz results, what do we need? Quiz ID, name, started date, and the players. Okay. This all data we have in the quiz state. It's just ID, I should rename it eventually. Quiz name is quiz state name. Started date, again I have this data in the quiz state. And the players for now are just an empty list. I will populate this list right now. Player score index contains indexes. I'm not sure if I'm gonna use this, probably, and answers. So I may enumerate this like index and score. I'm unpacking the tuple here. In player score, in player score index. And I should create this record quiz results player, probably. From all the data I have, including the player data itself and his score. So what about the name? Name, correct answers, total answering time, and answers. I have the player somewhere. Yes, this is the player. Players, and the index is here. And the name is here. The number of the correct answers is the score itself, the first dimension. And the total answering time is the second dimension of the score. And the answers, probably we again take it from the player data. That's it. Something's wrong about total answering time. Okay. Let me go back to the score and make it integer, because actually, let me check what I'm storing here. Player answering time, it's integer value. Okay. Fine. I believe that's it, and we may add this player to the results. Finally, we created the results. We'll return the results, or we might not return the results. We should store them. That's important. We should store the results, and we'll use again the state repository to store the results. We don't have this method yet, but we'll update the state repository. Where do you use it? Set state. Yes, required method is missing. We'll create it. This is trivial. I will copy and paste the existing code, but only change the key, and not so sure what else I should change here. Quiz results, and that should be it. Oh, I'm missing the quiz code. It might be inside the results, I don't know. For now, it's okay to have it this way. And the expiration seconds, as always. Quiz code, we have it in the quiz state. Now the results. What about the expiration seconds? I believe again we may reuse the started quiz expiration seconds. For simplicity, let's reuse it. Later on, we may decide on more granularity here. Oh. And that's it. We saved the quiz score, we saved the results, and we are preserving the results each time we are finalizing the quiz. But now we're going to implement an extra method for requesting the quiz results. I haven't foreseen this method here. The last method I have on the board is quiz answer, but we might include the results in the state. I don't want to have the results in the state. I want to implement it as a separate request. And it should be again a post request just because I don't want to include this data like quiz code and user token in the get request headers or the get request query string. Instead, I will implement one more post request. This is just easier for me to implement, not because that's the right thing to do. Let's go to the API endpoints definition, and the new endpoint will be get quiz results. It's called get. We already use a get verb in the name of the method that actually is implemented with the post request. But now I feel it better be a get request because might be we want to share the quiz results with some other people who didn't participate in the quiz. And the only thing we need to share the quiz results is the quiz code. So we might make it actually a get request. And we might include the, oh, it should be quiz results. The quiz code here. And the argument here is quiz code integer. But again, we are returning a dictionary. So results, let's copy and paste. But we don't have this method so far. Let's implement it. The implementation should be extremely simple. Here in the implementation, we are returning the quiz results. Let me go back to where we create the quiz results. Here, the same class. And we'll get the results using our state repository. Okay, self, state repository. Okay, we don't have get quiz results yet. but let's implement this. Read quiz results. Quiz code is the only thing we need. Quiz results is a return type. What's wrong here? Why it's highlighted? Let me check. Hmm. Okay, not sure about the mistake. We'll test all the logic with our integration tests later on. But for now, how do you define the key for the quiz results? It's simple. And we use this data to deserialize the results, this class definition. We are returning this data. And that's probably it. Read quiz results. Ah, I see. Read quiz players is the name. Yeah. Read quiz results. Let's go back to the quiz manager and replace this. What else do we do about results? In the quiz manager, there is nothing special to implement. I'm not so sure if we have to implement a specific check about the quiz finished or not finished yet, but let's see. If somehow our logic fails to check the quiz state on the client side and requested the results for the quiz that hasn't finished yet, we might get error, or instead we might return none. And also, I think that it could be good for us to return more than just quiz results. I would like to return the quiz metadata as well. Why? Because rendering the data is easier on the client side if we have all the questions with the quiz results. Because let's go back to this board and to this quiz finish state. And now we see that the player's answers should include the original question, the options, and some options will highlight. Will highlight both correct and incorrect options. So probably it's better to have both the quiz data and the quiz results in the same very request, in the same very response. So let's return here in the quiz manager, not only the quiz results, but tuple of the quiz results and the quiz data. And let's assume the quiz might has not been finished yet. So that's optional. And if we haven't get the quiz results, okay, let's decide on this later. If not results, then we return none. Otherwise, we return both the quiz results and the quiz data, and let's check where we have this quiz data defined. I don't want to repeat myself. I'd better copy paste for now. Let's see if we do this already. Oh yeah, we do. Now we have the quiz data. That's not so straightforward. In the results, we do have quiz ID, yes. And let it be the specific quiz data. And we return these two values, both the results and the quiz data. We are fine now. I don't see any yellow lines, yellow strips on the right side. And now I want to go back to the endpoint definition. Yep, right here. And here, I want to check the return value. If it's not empty, I will return this data. I will redefine the results variable, and I will return quiz requests, no, quiz results, as the first result dimension, and quiz data as the second dimension. Not so sure if it works, but eventually we'll test this logic by our integration tests. Might be this is okay. Now I'm going to implement the most complex test so far. For this test, we'll need two players, and we'll start the quiz. The second player will join the quiz, and then both players would be given answers for the quiz questions, and after a while we'll finalize the quiz. Probably one of the players would check the state of the quiz, and finally we'll check that the quiz state is finished, and the quiz results are stored, and we can request the results by this API method. So I'm gonna take the most complex scenario I defined so far. This is probably test give answer. Do I have this? Oh, interestingly enough, I'm having it outside of API package. I fixed this. Does it work now? Yes, it does. And let me run all the tests before I'm implementing a new one. Nice. Okay, I'm copying and pasting this test here. And this would be test quiz results. Test quiz results. First, I'm creating the quiz, but before scheduling the quiz, I wanted the second user to join this quiz. And we need the response because we need the user token. Let's say second player token equals response JSON user. And let's see how do we get the user token. It's just user token. But I want to simplify this big method, this big function a bit by refactoring this. And it would be join, join user, no. Let second player join. Nice, but where is the return value? Oh, the bad thing about this refactoring, it doesn't type annotate the arguments, but I do. Hmm? Myron? Yes. The same way, probably I'm gonna extract this request to schedule the quiz. I want to rename this user token by refactor rename first user token. Nice. Then my players would start answering questions. I actually don't care about the quiz answer response, and I will reuse this code. So first I would start removing this code I don't need, but I would encapsulate this code in a function. I use refactoring option as well as I used to do it before, multiple times. Let me extract method. And the method is give answer. I need the user token and I need the quiz code. Let it be just a user token, not the first one. Both users will answer. And the quiz code is an integer type. Return value is none. This is not it yet. I want to change this question index and I want to change this answer option. So here I introduce a couple more arguments. This is here. And answer is a list of integers. And this belongs here. Now the question number 1, index is 0. Let's check what is the correct answer. The correct answer here is yes, 2. The only option. It's a single choice question. At the same time, the second user is given his response as well. Or let it come a couple seconds later. Oh, I should rename it to follow the same style to the second user token. Now let the second player respond one more time, and the first player, let's skip the answer. Again, what's the interval between the questions? It's 13 seconds, and the quiz started at 2 seconds, so it makes 15, maybe 17. And what's the correct answer? I don't care, let me provide an incorrect one. Finally, I'm gonna check the quiz state to transition the quiz to the finished state. How do I do this? The existing test here, test quiz, no. Probably I don't have a test yet for checking the quiz state. Oh, I should definitely implement one. And I'll start from copy and pasting the existing test for giving the answer. I'll paste it here and rename quiz check quiz state. Test check quiz state. And first I'm gonna schedule the quiz. And next I'm gonna check the quiz state before it finished and after it finished. So quiz check state probably is the endpoint I'm gonna call quiz check state. The request is different. Quiz status request. It's simply just the quiz code and the user code. The answers here should be empty. Nobody answered so far, but the current question index should not be empty. Let me check if it works. No, I'm missing something. I haven't started my Redis instance. Let's retry. Not working again. Why? Oh, the JSON is different. Yes, most probably I'm expecting here the only state, but here should be both the state and not so sure. Let me debug this. The response was not found. Oh, I'm using the wrong URL. I'm checking the endpoint and quiz check status, the one I should call. Status, not the state. Okay. Let me just run it. Yes, it succeeded. Maybe I don't need some of the imports here. Now I'm gonna call this endpoint just to update the quiz state. No, this endpoint. I need this particular test for the quiz results. Yes, here again, after shifting time forward, I'm making another request and the quiz should already end. So 13 multiplied by 2 gives me 26 plus 2 gives me 28, but let it be 30. The quiz should be finished already. As I did before, I'm extracting this method, and so far I don't need the response. So I'll probably copy paste the previous one, call it check state, and execute this very request. I don't need this question index and answer. But I can call it now. Await this check state function with different arguments, just user token and quiz code. And now the quiz should be finished. Actually, I might check the state already. Let me return the state. but I want to parse this JSON. How do I parse it? Probably a response JSON is what I need. And the result value, now the return value is dictionary of type. The keys are always strings, and the value is any. If I check the response now, the status of the quiz should be, let me check what it is. I believe it should be finished. At least I hope so. State and status. Let's assert. It's finished. Let me run this test for the first time. It's red. Let's check why. Check state didn't work for me. Something happened inside. What exactly happened? Oh, now we are testing the code that ranks the players by their answers, by the precision and the time they took to answer the questions. And somewhere here we've got none type. The question did not contain correct answers. That's weird. Let me check what was happening here. Now what's inside the question? Oh, actually correct answers are 0. Probably this is the data I stored in this JSON. Yes, I expect some plural, but this is singular and I'll fix it here and here. Answers. Fine. Let me repeat. Something went wrong again. What was it? Interesting. I have this check for the current user role, and this check is definitely inappropriate. Do I need this current users? Yes, just to return one in the user quiz state. Okay. But now I'm rerunning this test again, and now it's green. That's great, and finally we can check the quiz state. And how do I check the quiz state? Plus minus the same way I used to check it before, but it will be a GET request, a bit simpler. I won't push the time forward a couple seconds because the quiz already finished and the result should be calculated. And what I'm missing is a user token. Let it be the second user. Quiz code is here, but the endpoint is different. And what the endpoint is, it's quiz result plus the quiz code. Okay. And it's just a part of the query string. So I don't need this JSON at all. Neither do I need these headers. I don't know yet what inside the JSON. But I will print it for now. And then I check what's inside to make the correct assertions. I don't need this breakpoint any longer. Yes, I have the result. The result is not exactly what I expected because I forgot to change this post and method to get. Now the result is a dictionary, and it contains both the quiz result and quiz data. First, I would check that both are in the result. Data is not empty. That's something I want to assert. I want to check, test, and the quiz results are also here. But now I'm interested about the results. First and foremost about the players. Do I have some? Yes, I do. I see it. Let me introduce a variable here. And let me check this variable, this array of the players data. I can make this font bigger, but it's trivial. In the players, I expect two records first, so I may check it this way, two players. And the first player is the one. Let's see, it should be probably the second player. Because the second player provided two answers. But not so sure because the answers of the second player weren't correct. And the only difference between the first and the second player, for the second player, it took a bit less to answer the second question because the first user didn't answer the second question at all. Or this means that the first player took all his time for answering the second question. It's a bit of a mess, but still. Now it's unclear to me who the first player is and who the second player is. Let me check. The second player is the one with the name C. Okay. Let me rename it. It will be just second. And the first player, the one who started the quiz, let me leave here. Let me leave him untouched because I would probably check his name in one of the quizzes. And the start quiz I use in almost every test. So at least we know who the first player is. Let me debug the test again and check the response. The response value, the quiz results, the players, the first player is the second one. It makes sense because the second player answered two questions. And it took the second player, let's see, total answering time is 3 seconds. Let me see if it's true. So when the second player was answering the first question, it was 2nd.2 after the quiz started. So we have 1 second here. 1.2, but it was rounded to just 1. And for the second question was asked 13 multiplied by 2 is 26 seconds plus 2 seconds. Oh, sorry. Just 13 seconds from the quiz start makes 15. And this is 17 seconds. 17 minus 15 this makes 1 second. 1 second here and 1 second here. Probably again this was rounded a bit in a bit different way, but eventually we have 3 seconds. This is the plausible result. a good estimation. And for the second question, for the first user, the quiz commander, answered the first question almost immediately, 200 milliseconds after the quiz started. But he didn't give any answer for the second question, and the default interval is 13 seconds. That's why it took longer for him. The number of correct answers is 1 for each of the players. So actually the results are something I expected, and probably for the sake of brevity, I don't want to make this test more complex because again, it's a pen test. I need a simple application to deploy it in cloud and to focus on the deployment, but not on the logic. I believe we are good with this test, and that's super cool because now the backend part is done. Just a bit of refactoring I want to apply here, and we are ready to go for the next step for the front-end implementation. Why I don't feel we can move forward? Because we will be having hard time while trying to execute to perform a tricky scenario, and we'll be having errors on the server side. And let's check what's happening if we have an error on the server side. Let's check the simplest request among our tests, and this is quiz topics. And let's say something goes wrong while we are trying to obtain the quiz topics. We'll go to the quiz manager, and the first request we implemented, it's get quiz topics. Let's spoil this code and rename the variable that does not belong to the class. So here I'm expect an exception, an unhandled exception. But how this will work? If, for instance, we don't want to check the status code for 200, but expect that the status code is something else, probably 500, and ideally, I would have here an error description as well. Let's see if it works. It does not work. Our code didn't return anything, any meaningful description was returned to the caller. So our client wouldn't have an error description. And while running our frontend and executing the request to the server, we won't be receiving meaningful errors, meaningful status codes, and the payload, the description of the error in the body. I want to change this, and I'll check what options do I have with the Fast API implementation to return the error detail to the user, to the caller. I would simply go and ask internet about options in the Fast API to catch exception and return the detail to the user. I have a whole article here. And let's see what options do I have for intercepting exceptions. Now there is something, and this is a decorator, application exception handler. I can define a function on the top level, somewhere next to the Fast API application declaration definition. And in this handler function, I'll be receiving a specific exception. I might as well receive a generic exception, just an exception class. And I'll create this exception handler. But here again, I might be disappointed if I apply this scenario in a real-world application. I stumbled upon this problem quite recently, and now I know that before defining the exception handler, I should, oh, sorry, only after defining the exception handler, I should allow cross-origin request sourcing. I'm going a bit ahead. We might face this problem later, but while we are implementing the front end for our backend locally, we'll probably be having different origin for the request and for the response. Eventually, we'll be for our AWS cloud distribution, we'll be having different addresses of the API endpoint and of the static website. This might lead to a problem even on a deployed application, not only for the development phase. This means I should care about the cross-origin request sourcing in advance, and I should care about it before I implement the global exception handling. I'm going back to my Fast API application definition, and here I'm adding a router, but after this, I want to add the middleware to support cross-origin requests. So what's inside Fast API? Allow cross-origin requests. I just took this link for reference. I love copy pasting from the internet. I should import it from somewhere. Not so sure where I get this class, but let's check the Fast API. Do I have course? Yes, I do. Okay, let me first check nothing is broken so far. Make test. Something's broken, but not because I added this course middleware, but because I added this error intentionally. Now, let's talk again about exception handling, and let's go back here, handling errors. There is one option for me to add the exception handler through the decorator. But if I implement the exception handling this way, there is no guarantee that this middleware will be added before this course middleware. And with the course middleware included before the middleware that I defined through the decorator, our cross-origin requests won't work in case of the error, in case of the exception that we return. This is something buggy about the Fast API implementation. I just know it in advance because I stumbled upon it. But let's not go this hard way, and let's be aware of this potential problem and avoid it adding the middleware before we add the course middleware. I checked this reference and I didn't find a way to provide this exception handling without the decorator. So might be I'm doing something wrong, but I still sure this opportunity of adding the exception handler directly as I do for the course middleware through add middleware exists. So I would go to OpenAPI chat and ask it, can I implement global exception handling in Fast API without What was the proposed solution? Without the exception handling decorator. Chat says, yes, I can. Oh, that's not something I expected. I don't like the way it uses the decorator again, because I want to control the order in which I plug the exception or general handlers to fast API. So I would reformat my question. It says that's not possible, but there is an alternative. Let's see. Let's see if it works. And remember, we need this before we add the course middleware. The course middleware. I'm not sure if it will be JSON response from where we imported it. From fast API responses. Okay, let's try it. And what is the request? Again, that's fast API. Fast API request. Hmm. If this is a dictionary, let it be well formed. Now I run my test and see if it's not throwing exceptions any longer, but it does. I'm not quite happy with this solution because obviously it does not work as I expected. Let me add this function as a middleware, as I do here. And the middleware is for the HTTP protocol. What is wrong here? Maybe I'll just pick the middleware and provide it with this function. Let me run the test again. No luck. It can't return the JSON response. What does it say specifically? In await expression. So this probably should be async. Async, handle global exception, and interesting. Again, this is not an exception handler. So I should first try the regular flow. I need a bit of advice on this middleware. How do I implement this in Fast API? Let's see, my middleware now consists of the request and the call next. Okay, this is a normal flow. Okay, I should respond. I should respond with something that I get from the call next. Let me implement my handler this way. Let me try the normal flow. And if I get an exception, I will return JSON response, status code, and this might be the body. But I just return this. I don't have to declare a variable. Now I hope it's it. That's it. Yes, I'm adding my middleware the same way as it was proposed. Cool. Let's run the test again. And now the test is green. But let's see if we have the error code here. The response is 500. And let's check what response body is. The response text is internal error, quiz date object has no attribute name not found. So later on, when we be implementing our frontend for this particular backend, we'll be having nicely formatted errors with some error code. It won't be just a generic 500 error. We shouldn't go to the server logs to find out what was exactly happening. And this would be extremely important as soon as we start testing our application as a Lambda function in AWS Cloud. But now I'm gonna return my changes, revert my changes. I don't need this. And in my quiz manager, I don't wanna try this name not found. And I'm gonna check all my tests are green. Yes, they are. I already told you that was the last thing to do until we start implementing the front end. But now I still feel something is unfinished. And I don't like this warning. Where do we get this warning? While we are providing the JSON conversion function of one of our PyIdentic classes with the data that misses an obligatory argument. And let's see what the argument is. Information is true. Let's see where we use it. This is the quiz metadata repository. While we are reading our quiz data from the file, we are relying on the quiz path, the quiz ID. This is actually the name of the directory we are reading the quiz from. And I don't like this approach. I want to change it. So instead of this, let's introduce the quiz ID here. Let's go back and check the attribute name. The attribute is inside the quiz topic and it's called just ID. Okay. So I'm gonna introduce this ID. I'm not sure, might be it's a good idea to have the directory name and the ID of the quiz the same value because it gives the user the opportunity to create more quizzes in the S3 bucket and the quiz name won't collide. But for now, I just don't like this warning message. And also, I'm not so happy about long names, long paths. So I would provide the quiz ID here as a JSON key value. No, not in the question, definitely. And I will do the same for the second quiz. Now I can rename quiz folders, subfolders to something else. Let it be just quiz 01. And this would be quiz 02. Now let's go back to the deserialization code in the quiz manager. Is it in the quiz manager? Read quizzes, it's here. And we don't have to pass this quiz ID. We don't have to replace it. Still, I believe, I hope at least my logic gonna work. My test will be green without any orange warning message. Yes, it works. Now that's it for the backend part.